Well, hello, good morning. Thanks so much for joining me in my shop while I get ready to do another VTVM. Just for a little bit of background, all three of these units, as I remember it, I acquired all three of them at the same time at a yard sale. That's how I remember this. Now, that may not be true, but certainly they've come to me in this way, kind of an opportunity. I didn't go out searching for these. I didn't buy them over the internet or anything like that. This is what I've acquired. So I've used this guy quite extensively for years until just now when I've fixed them up a bit. I've really never made too much use of this one or this one because how many voltmeters do you really need at one time? Occasionally I want to have two, maybe once in a blue moon, 3 meters going at once. It's not going to happen very often, but nevertheless, even though this guy might not see much use, I still want to go through, check them up, and make sure it is available should I want to use them. And my plan is to rely on these two and mostly on this one. I really like these big pointer meters. I prefer them way over the digital display. But of course the digital modern meters are very, very accurate and precise. These are not terribly accurate and not quite so precise. You can't read 3 decimal points with one of these, but then who needs to? So today what I want to do at the very least is plug them in and check them out and check how accurate it is and just get a feel for how well it's working. First I'll be smart and inspect the cord here, which I didn't do at the last one of the last meters, and found out at the last minute it had all kinds of soldering iron strikes on it, like a lot. The person who had it must have had the meter sitting on their bench with the cord running across it right where the soldering iron got parked, or something like that must have been going on. So this cord's fine. It's really stiff. So I'm looking right in here to see if there's any exposed copper. That's a very likely place to stick your finger. You can see it doesn't seem to be strain relieved very well at the back here, so exactly what's going on inside raises a bit of a question mark. I have a very safe way of plugging in question marks here in my shop, which I will do. And thank you for a comment pointing out when I think I was saying on one of my previous videos, I'm not so sure what would happen if I placed a short circuit on this. Would the current flow into the short circuit be enough to pop the breaker in my house? This doesn't go straight to an outlet. This goes to a isolation transformer, and that transformer will only put through so much current into a short circuit way up here. So I was just muttering about if such a situation did occur, and I did not have the dim lights in because that's normally how I'm protecting myself from a dead short on this equipment. There's a chance that my house circuit breaker would not open on a fault inside my shop here, and what that would lead to almost certainly is a fire. So having thought a little more about it, I've decided I'm going to put a fuse in my little control panel here. I'm just saying this for the sake of the person who pointed this out, that what he commented on has got me thinking pretty hard. So I'm going to put a fuse in here. This is my switch panel for turning this outlet on and off. I'll mount a fuse right in there. I don't know, 5 amp fuse or something like that. Okay, now back to this meter. We got it plugged in. We will now turn it on. The switch itself is off. And it certainly is off. We'll switch it on. It's a very, very low current draw in a meter like this, a device like this, so it didn't even light these lights at all, assuming it's come on. Yep, so with 123 volts supplied to it, normal. Give it a moment to settle down. I see it's reading up scale. So the first mistake I made is I did not check the zero, mechanical zero. Let's turn the power off and we'll adjust the mechanical zero first. Okay, now it's on zero. Power back on. The circuit inside this meter from the description I read in the manual, yes, I've actually read the manual for it already, The description it describes a circuit almost identical to these two meters, using the same two tubes, using the same concept of placing the meter movement in the cathode circuits in the 12AU7 amplifier tube. It's on AC right now, and you can see it's lifted up a bit. Now, I did read in the manual for these guys that this is a typical problem with a meter like this set on AC. It cannot zero back. I'm not saying that's what's happening right now, but these meters contain circuitry to ensure that on AC volts open circuit the meter will relax to zero. Let's see if the zero adjust moves this. Yeah, it does. So whether there's a problem here like that, I'm not suggesting that. So there we are, AC volts. DC volts shot backwards. DC volts positive. Okay, just a high impedance input does that. And I know there's no battery. Oh, I don't know that there's no battery in here, so let's check that out. Flip it onto ohms. And I expect if there was a battery that the meter would go upscale. So now as for the pointer. So this is a meter, a test meter lead I acquired years and years ago. Nothing to do with this meter. It has a fuse in it, 1.75 amps max. So it's a fused test lead for other purposes, but I've used it here only because it's kind of nice. See, there's no negative coming out on this at all. So in this meter, you plug another a negative wire into here, bring it out for clipping it onto the chassis or B- of the item you're testing, or whatever you want to do with it. It's not contained in here. And then this is where you would have a test lead come out for measuring AC. So a couple things about this. First of all, these terminals here are just simple terminals. There's nothing simple about this one. Well, it is kind of simple too. It's a contact in the middle and an outside piece. So the outside piece on this goes nowhere. The original, you know what, I don't know about the original, to be honest with you. It's a little bit in the manual I've seen already. So, but why, why they would do the DC and the AC so very differently. I mean, that's sending a message here, which I'm not sure I can get it. So what's lacking in here, although it has a fuse in it, is a big resistor, a 1 megohm resistor. The proper lead coming out of here for DC measurements has a 1,000,000 ohm isolating resistor inside here. And this is fused. Fused. It's plastic fused. You can't open this. It is what it is. So again, I still haven't read up 100% on why bother with a 1 megohm resistor in here. It's 10 megs impedance in here, and in the manual it quotes the total impedance as 11 megohms because it's counting the one that's in here. That's not in here. That's in here but not. Let's read some voltages here and we'll see what we get out of this guy. I think these are pretty small. You're looking for small. You're looking for small. That's a little too small. That looks too big. Well, that's funny. This is kind of an unusual size there. So this is what we'll have to use. Barely gripping. Yeah, I got nothing that'll fit nicely in there. Clip lead. put this on my, start with a low voltage power supply. That's a little safer than trying some higher voltages here. $20 volts on the end of these leads right now. 20 volts DC. So I can tell when in using this meter, and I look down at it to try to make settings, just because of my eye angle and whatnot, I can't see any of these numbers. They're all hidden by these knobs up here. It's kind of a bad ergonomic design. The person designing it imagined themselves looking at it like this all the time. The good thing is I'm going to put this up on my shelf. It's going to be up this high. Oop, out of view of the camera. So I should be able to see it. But if you have it down on your bench, you're going to have to get down like this all the time and look at it. These meters don't have that problem because the adjustment controls here do not have big whopping knobs on them. They're in the same position, but they don't have big whopping knobs. So you have a clear view of the setting. And in this meter, they reverse them. They put the adjustments down here and they put the control knobs up high where again you can read the controls. I'll bet you the designers of this discovered that this is not a good arrangement, but only after they had built a whole pile of them. People phoned them up and said, I can't look at, like, minus DC volts is way under the knob there. You never see it from this angle. So okay. Small things. So 20 volts we think we have here. So we're on, get it off ohms, we're on positive DC volts. 50. So 50 should be up around the middle of the thing. I'll just zero it this way. A little calibration will fix up the lack of balance. Why is it going the other way? Because I plugged these leads in backwards over here. Let's make it, let's be true to the colors. Okay. Well. Excuse me. That looks a little low. Okay. Very dry in my house. Well, so a low reading can be, off the top of my head for all kinds of possible reasons. Weak tube, bad parts in the circuit inside, the B plus is not present in here properly. All kinds of things could cause this. But for sure, we're on the, I have to keep ducking down to read the scale there. We're on the 50. We got 30 coming in. No, 20. We have 20 volts coming in, no doubt about it. So, of course, it should be up in this range. We'll try another scale. It can be the scale voltage divider resistors. I'm really banking on it not being. We'll go to 15 and watch. It should go right over. Isn't that something? Well, it's consistently bad. 5 volt scale. Oh my gosh. 20 volts on it. Is this really making it there? It's got to be making it there. Let me turn it off just to make sure. Yep. Yep. So this meter's way off. That's my determination there. Really no reason to test the higher scales because every scale is in the same proportion off. Let's try DC negative here. So to do that, I'll just reverse these. I mean, all this does is reverse the voltage that's applied to the meter movement. So this should give exactly the same. Exactly the same reading. What is going on with this guy here? Oh, let's try that. I'm moving the wrong controls. What just happened there? This is a good example. I can't read the scale. It's half hidden. I make a mistake right away because the scale's not staring me in the face. That's my excuse. Okay, so we still have 20 volts coming. We're on the 15 volt scale. 20 volts is up here somewhere. I think we're getting the same readings. I don't know what I was doing there. Oh, wait a minute. So on the 5-volt scale, it's just over. Let's reverse it again, because I didn't think it was just over. Don't really know what I'm discovering here either, but different reading. Well, let's see. I was going to say maybe that implicates the 6AL5 because it's a rectifier, but no. They were doing DC measurements here so far. Well, something's wrong. Something's wrong there. So we'll try AC volts and see where we get with that. I think I'm going to pick it up right here. Is that a smart move? No. So first I got to get this onto the negative terminal here. Some of you were a little anxious about the fact that I used a so that's the grounded side. Let's see. This is plugged into my isolation transformer. So I cannot get a fault through to the hydro neutral. Boom! Put that on there. We're on the AC. The AC, I say. AC, I say. So 150 volts. Supposed to be RMS. Let's turn on the power. Hello. Careful you don't short. Hello. Oh. AC is over here. Okay, hold it. Turn that off. AC, right. AC is from a different test lead. Who's calling out here? Do you want to see our visitor cat? It's right there. Look at that guy. That's Boo Boo. Boo Boo, you big hairy fur guy. Come on. Come on in. Come on. Boo Boo, come on. So that cat's been visiting us for a couple of weeks. He's going to go home in a couple of days. And after 2 days of getting used to the house, he's turned into just a third cat in our house. He's getting along great with our own cats. He looks like a big honking cat, you know. He's a skinny cat with a great big head and a pile of fur like you can't believe. There he is. Boo Boo. No, he's busy now. He's gone to play. So, you know, that's a scary thing, bringing another animal into your house. You never really know how it's going to work out. But it's worked out just great. In fact, we're keeping that cat now. And the owners are not getting him back. So I got to plug something in there. Do I have another skinny thing? I do not. I have one of those. Well, that would go in just perfect. That being the case, I could kind of cheat my way around here. I can just find this. This is a terrible way of doing it. This would be terrible. Is there a mega ohm resistor in there? Nope. Okay. So, as a crummy way of doing this, you know what? That doesn't really... Why such a weird size of plug? That didn't work. It did not work. My bad idea turned out to be a bad idea. Some tool I can just shove in there for now. That's pretty good. This is not exactly the best way to do things. Now I need somehow to make contact here safely. Oh my gosh, this is crazy. Do I have a spare? They did not have a spare. Oh my gosh. I wouldn't care if this was just some little voltage, but it's going to be line voltage. Okay, I think this is going to work now. No resistor in here. That's there. That's pretty good, actually. That's pretty bad. AC volts, 150 scale. Power on. There it is. There's the reading. Where'd it go? Oh, I think it was just a bad contact. There we are. So on the 150 volt scale, we're reading all of 20 volts when it should be 120 volts up here. So clearly, this guy's got some sickness in him. I don't think we need to do any more testing. The story is clear. Story of whoa. Let's pull these out of here. So I will be making up lots of cords for these meters once I get them all done. Pop the back off that. Take a look inside. Power off. Might as well take this off too to get it out of the way. That's a nice. I made this cord up really nicely one day. I never checked the meter for accuracy. Okay. Like, oh my gosh, the meter movement is flopping right off. Huh. Okay, glad I noticed that. So you could have this on your bench, and you can pull the guts out forward because the screws are in the front. I suspect that's why they're like that. I have a older meter where the power cord comes out the top. Now you might say to yourself, why in heaven's name would you want the power cord to come out of the top of a meter? That's what I said when I first saw it. My son picked this meter up at a yard sale just because he knows me, and gave it to me, and I'll show you why the cord comes out the top. So there's the meter. I keep it up here high on the bench, but when I go to use it, I bring it down to the bench. Let me show you. It's really heavy. I'm bringing it down. Look, the power cord. So I think that's the idea. I think that's what they reasoned out. Probably it's just a false story I've made up. It makes me feel good, but it's actually not true. Okay, up we come. So right away I see a big capacitor here. I see the battery is out of it. Oh. Refer to this number when requiring service or parts. Okay, so it requires service and probably parts, so I better refer to this number. 83Y911 512041 507. Okay, so I've referred to it. Now, so the layout of this looks just like the other meter. Is it identical? Oh my gosh. Okay, so here you see this evil rectifier here. This one looks evil. Now, we're not plugged in. Seeing if there's any heat left in it. Not really. That guy's gonna go. We'll put a silicon diode in there in place of it. Let's get the close-up camera happening here. So looking for overheated parts. basically overheated parts, or anything that looks out of sorts. Got all the values written right on there. This is a kit, right? So they make it as hard as possible to make a mistake. Again, it has a lot of ceramic capacitors in it. I haven't seen any paper ones yet. Well, am I seeing things? That same resistor that was... It's exactly the same resistor as on the other two units. Huh. Who made this? KG. Who's KG? KG 620. Allied Radio, Chicago. Well, it's pretty interesting. I mean, this is exactly the same resistor here. Every time I touch this, it seems loose. My imagination. So again, we see all these wonderful, high-quality precision resistors, and you know, just looking in here, the wiring is the same. I remember seeing a lot of these wires just going across in between resistors. I remember the pattern. So this is really much more similar to the other meter than I would have guessed. There's that white capacitor. So that one says right on it's 1600 volts. It's a different style of capacitor. I don't remember the pilot light coming on. I see it in there. Looking everything over. So nothing leaping out at me. There's nothing obviously bad here. Maybe we want to start with doing some tube testing. Maybe that's our starting point. That's a 12AU7. Any reason to check anything else or to question anything else off the bat? No, from there, you know, it's going to be a hunt and peck to try to find a defective component. This capacitor, you know what? There may be no B plus in this thing because of this. Right off the bat, we can do a quick B plus check on this meter. The B plus will be right on this capacitor. Let's do that. I'm going to do it. I'm not going to use the my nicely fixed up VTVMs. I'm going to continue to use a fully isolated meter, but I'm not familiar with the circuit, and I don't want to think too hard right now. So a human's nature is to minimize thinking. It's human nature, because thinking and, you know, using your head hard consumes a lot of energy. And if, you know, although in today's world we really don't have to worry about running out of energy because we can always grab a Pepsi, you know. Certainly in the long run, biologically, that's an issue. So the tendency, the natural tendency, is to not think too hard unless it's really, really necessary. There we are. So be aware, I'm not thinking too hard. I like to think that's why I'm skinny. I'm a skinny guy. I'm burning all the calories in my head. So it's plugged in. Switch it on. Power on. Power on. Last meter, what was the voltage? 160, around 160. This is a 200 volt capacitor, so you know it's the same. It really resembles the other meter. The other. Okay. here. Yeah, right like that. Now we're gonna touch. I'm gonna touch this guy up here. Watch your fingers. Don't be shaky. 53. Across the capacitor. I'm going to read across the diode here. I'm not sure this is really an effective thing to do. A huge voltage dropping across that. That's the problem. That's the first problem, is getting rid of this rectifier. Power off. Okay. In fact, we really shouldn't do anything more with it until that's out of there. I have heard, never experienced this, but I have heard if these things reach a point of failure, they overheat to the point where they really fry up, they produce a lot of horrid smoke you never want in your house. And yeah, so I've heard the horror story on that. Let me see how it's done. So it's two flat tabs pushed through and bent on the other side. I'd be able to just pull it out. Or I have to bend up those things. I could just cut them out of there. I could just get into a big pair of cutters and just cut these tabs. I cut one tab, everything gets a lot easier. Let me see if I can do that. I may not be able to. Just double safety there. I don't know if I can cut through this stuff. It's kind of a long shot here. I don't think I'm going to be able to cut it. Well, take that back. Okay, so I'll just make it a little easier to get it out of there. So I'll only be pulling on one tab at a time instead of two. So while the soldering iron is warming up, what should we put in there for a rectifier? Oh, you know, even a one amp, or just a. There's all kinds of them that we can put in there. One that can do an amp, like this is probably a 10 or 15 amp. One here. Okay, I got all kinds of them. This is a small part of my rather stupidly large collection of diodes that I have ended up with. Okay, we're ready to pull that out. First, let's bend this up out of the way. Luck, it'll almost fall out here. There we are. Just as I had hoped. So if you try to get that out with both legs hooked up to this thing, it's quite a challenge. It would be quite a challenge. Okay, grip on that. There we go. In case you didn't quite follow what the challenge was. Yeah, see how that's on an angle there, so it goes through, bend it back, solder it down. Yeah, very simple. Just put a nice rectifier in there. Okay, let me hunt down the right size here and get that done. Okay, let's pick a diode. I'm going to use the 1 amp diodes, the 1N400 series. So 1N400, 4001. That's not going to have enough reverse voltage, so this is probably the good one here. 1N4004. I think this guy has, how tiny he is. I think he's got enough reverse voltage is 1 amp through 407. So let's look at a table and we'll pick, because I've got all these. I've got samples of all these 1N examples. You know, I got some 3 amp guys here too. Yeah, 3 amp. And then I've got endless piles of them in here. I got too many. 402. Okay, let's look at a table and we'll pick one. So I just found this table by hunting on the internet for somebody selling diodes. Here's a table, and it shows the different 1N4 series and peak repetitive reverse voltage. Working peak reverse, there's that word working again. DC blocking voltage. I guess it's saying these are all the same thing basically. So you see a 1N 4001 low reverse. You couldn't use that on a power line. Wouldn't want to use that on a power line. Now we're getting somewhere. 200 volts. This would probably work. Power line peak voltage is not 120. It's 169. So say 170. So you got to get clear of 170. And if we're here, you're really clear of it. What's this? Non-repetitive peak reverse voltage. So occasionally you can whack them with this. RMS reverse voltage. So they just oh, is this peak? Yeah, peak. Whoops, I didn't see that. Look down here. Ooh. So now we really want to go to the 4004 at least to get that 280, because 140 not enough. And then these are all 1 amp guys here. Okay, so let's pick the 4004. I kind of thought that would be the guy. Oh, so tiny. Gonna have some trouble imagining 1 amp getting through that. Now we got to get the polarity right. Okay, polarity. And I'm always hesitant on this. Somehow I've never ever firmly learned a rule, like so many things I just can't. I can never be sure about what's in my head and is that right. So I'm going to consult the internet quickly here and see if I can quickly find something that tells me what I should already know, but I don't. Okay. Diode and LED polarity. Diodes only allow current one direction, only polarity. There's two terminals. The positive side's called the anode, negative one's called the cathode. Well, thanks. That didn't help one bit. There we are. Positive, so the negative end is the end with the white bar. Positive end is the end that we want to go to the, so, okay, I got it now. Just one sec. Here. Positive end. Negative end is the end with the bar. Maybe I could remember that if I thought the bar looks like a negative sign. Positive end, we want it to go to the positive end of this capacitor. It's got to go in this way. Solder here. Sorry, it's a little out of focus. Ouch. There we go. here. Good. Good. Did I put it in the right way? Yes, I did. Now, what if I put it in the wrong way? You know what I should be doing? I should be changing this capacitor right now too. You should not hesitate here. Yeah, really. I should not hesitate. So I will do the 100 ohm. I'll do the same thing. 100 ohm, 50 diode capacitor in there. Have a nice sunny day coming here today. It's about -5. Blue sky, sunshine, snow, white snow on the ground everywhere. Got a little bit of fresh snow early this morning. Getting ready for another significant snowfall coming later tonight. Sorry about the focus going on its own there. I'll get this done. Okay. I forgot the resistor. Whoops. Okay, let's keep going. Now, start over. So the purpose of this resistor I'm putting in here is to slow down the inrush current, the charge current on the capacitor when you first turn the unit on. If you allow too much current, that little diode just isn't going to survive the experience. So a 100 ohm resistor there should help him out a lot. Too much wire here and there. Right close to the, that's pretty close. It'll do though. pretty close to the body of the capacitor. That's what I'm talking about. I'm applying heat that close to the body of the capacitor is not the best thing. Gotta have a little bit of lead there. There we go. Bingo. Do that one quick. There we are. Perfect. Well, we're going to find out how perfect it really is in just a moment here. So let's see, the first thing I want to do is I want to know what the B plus is right off the bat to see that there's a change. So I'm going to want to grab these leads and I'm going to want to go like that or like that. I'll read what's on the capacitor. 200 volts. Plug in using the dim bulbs. Okay, so if I got that diode backwards, remote chance this will explode. Okay, no explosion. That was good. That was a quick test. Now, in order that I don't have two hands, I have to make two contacts hurriedly. Okay, well, there. In fact, you know what? I could even. I don't. I click the other one. Why not? Just keep going. Just keep going. Right across the capacitor. Positive on the positive. Not that it would matter. 200 volts. What do we got? Show them what they got. Oh, it's the same voltage. Well, that is not a good outcome. That is a crapola outcome. What has happened here? What has happened? Man, it's starting to sound like a bad power transformer. Don't, no. Did I get the diode incorrect? Let's see. Let's check that first. Is the voltage building up the right way? So I have the positive lead of the meter hooked to the positive side of the capacitor. We should get a positive reading. Oh my gosh, I'm a dork. How did I get that booped up? Is it worth repeating that? Am I doing something crazy here? Definitely not. I'm reading it the right way, right across the capacitor. What a dummy. Okay, well, we don't want to put any more power into it if I have that backwards. Now, a smart person would edit this out of the video and you'd never know I made this idiotic mistake. But to demonstrate once again how I lack smarts, I will leave this in the video for all of you to see and marvel over. This little puny diode. Now, what did I just do? Did I just rotate it properly? Yes, I did. A brief period of being charged up backwards on that capacitor, the voltage involved, there's really no chance that I've done any kind of serious damage to it, in case you're wondering. Put a higher and higher voltage on a capacitor, electrolytic capacitor, in reverse, and at some point, either given enough time or enough voltage, something's going to happen. have seen electrolytic capacitors explode on application of voltage. None of mine, but when I was in college. So I know what happens. I may have opened up the odd piece of more modern equipment and found a popped open capacitor. I think they can pop open and blow their guts out. I think I've had one like that. I think, come to think of it. Now, why is this meter falling out also? I don't want to forget about that. Seems as solid as can be here. This is not plugged in. I thought the whole thing was falling. It's falling out the bottom, maybe. It's falling out the bottom. Was I seeing things? Well, I could have sworn this was flopping out. Looks to me like there's 4 posts going in the corners here, and they all appear to be there. What did I see? I don't know. Okay, ready for another test. This time we should see a positive voltage. I want just to review my lead thing. I'm not making a stupid mistake. The red lead is in the positive. It's hooked up to the positive side of the capacitor. Without a doubt, the negative side is hooked up to the negative. Okay, I can't possibly have this backwards now. Away we go. Plug it in. That's the part that's missing here. Okay, hopefully you're going to see 150, 160 here. Hot diggity dog, 170, well over the reading of that capacitor. Settling out at 170. 160, 170. So we had an interesting discussion about this. The suggestion is the older electrolytic capacitors, like this one, would have a rating on it of, let's say, 200 volts. But in fact, all the manufacturers know that this is going into devices like this, which have a power supply rise voltage briefly and then come down and settle in. And sometimes that rise can be 100 volts higher than the settle voltage. So they put a number on here, 200 volts. Sometimes they put working volts there, and what they're trying to say is this thing can sustain the 200 volts all the time. But what they're not saying, but is true, is it can also sustain 300 volts for a short period. A few seconds or minutes or whatever, repeatedly. Every time you turn it on, it gets a whack, but it's okay. So in fact, the rating, really, you could put 300 here. But if you put 300 here, people would get confused and start putting it into circuits that have a 300 working volt rating, but a peak of 500. You see what I'm saying? This is in the old days with this kind of power supply. In today's equipment, this doesn't happen, and transistorized power supplies don't go way up while they wait for tube heaters to heat up. That doesn't happen. So there's no need now to put low ratings on capacitors, secretly holding back the fact that they're good for another 100 volts or something. So the idea is modern equipment, the rating is very firm. The rating on this capacitor is 160 volts, and I'm applying 170 to it. What am I to do? Well, put in a higher voltage rating capacitor. I could do that, but why do I want to waste an even bigger capacitor in this meter? So let's see what happens if you have too high a voltage on these things. They must develop a breakdown and a short circuit. This must be the problem with them. Go from 160 to 170 is going nowhere. Well, that's not even a 5, 6, 7% increase. The inrush voltage or rise voltage, I didn't notice it, but it's probably a little higher yet. Capacitors must still be built with a certain range. They're not going to make them so that at 161 volts they blow sky high. They just wouldn't manufacture it that way. So my opinion, right or wrong, is this is okay. I'm going to leave it like that. This meter will seldom be used. Just be used in sort of extreme circumstances. Now the question becomes, we plugged in, make sure the power's off. The question now is this meter now accurate? Because really, this was the guy killing it, this thing here. This was eating all the supply voltage. Let us find out. It sits right on the son of a gun. I can't set it like that. We gotta set it like this. Still not perfect, but that's a lot better. Okay, so here we are sideways. Got to realize now gravity is affecting this meter pointer a little bit. Probably not enough to worry about. Switch is off. Scale setting is 50 volts. We want to test against. Let's test against the DC voltage here again. Okay, I got too many voltmeters and leads here. Yeah. Okay. Okay. DC, we'll switch on. Power on. Switch on. Good. No lights. It's got a nice indicator light there. You can probably see that quite clearly. The green light there. Nice, I like that. Put it on DC plus volts. We got 20 volts on the clip leads. 20 volts. Okay, ground. We need that ground deal again. What did I do with the little tiny? There it is. Not very satisfactory at all. There's this lead here. You know what? I took the cabinet off. I can just clip right on the back here. Okay, so negative to negative. The right lead now. Look at that, go up the scale. Holy smokes. Okay, so we're on the 50 volt scale. 50 volts. It's reading exactly 30. And I really should be reading 20. So we've really improved it now. It's super good. It's better than ever. Okay, so probably the zero adjust wasn't right. Let's go back and check that. Take the voltage off. Put the zero where it's supposed to be. About there. Put it back on. Wow! I got even more voltage now. It's fantastic. This is a great meter. You don't want some meter that's going to read this low. You want a meter that's going to read it high. Give you everything that's coming to you. So, next step on this guy is calibration, I think. Or, yeah, I think calibration would be the next thing to do. There's no use going through all the different scales and comparing them and that. They're all out right now. So, I think it's come along pretty good. Basically, it's exactly the same as the other two meters in terms of dysfunction. Those other two meters had silicon diodes in them. Now, one of them was a replacement diode. I think I'm the guy who did it. Probably got that one in backwards to start with, too. But I don't recall now. It was so long ago. Great. So calibration, and got another good meter. So thanks so much for watching, and we'll see you in the next video.